Okay, good evening, class, and welcome. My name is Chima, and here I'm going to be taking you performance management. And today's lecture, the lecture topic is limiting factor decisions. Okay, so we are going to be looking at limiting factors and how we can manage scarce resource. This topic explains the concept of limiting factors, how to identify them, and how to formulate an optimal production plan where there is a single limiting factor. Just a moment, please. Okay. This topic, limiting factor decisions, explains the concept of limiting factor, how you can identify them, and how you can formulate an optimal production plan where there is a single limiting factor. Now, when you want to use this limiting factor decision-making theory, there are certain things you have to bear in mind. First of all, the problem that this decision-making technique aims to solve is a problem involving just one limiting factor affecting the company or the firm at a given time. Okay, so when you are solving a problem for the organization, and let's say you want to meet the demand of your organization, the organization wants you, giving you a target that they want to make sales to the tune of 10 million naira in a month. Let's assume that. And you just have only one factor that is limiting you from achieving that. So how do you deal with that factor so that you can maximize your profits or contribution? That is what limiting factor decision-making technique will handle. Now, when the organization faces more than one limiting factor, then we will use what is called the linear programming decision-making technique to solve that problem. Now, it means that after this topic, which is limiting factor decision-making, it is possible that we'll move to linear programming to see how we can use this technique to solve two or more limiting factors. So somebody say he can't hear me. Can you hear me now? If you can hear me, please go to the chat room and type you can hear me. Okay. Say you can hear me now. Thank you so much. All right. Now, we are saying that in this topic, we'll be dealing with one limiting factor. When we have more than one limiting factor from 2 and above, we will be using the linear programming model or technique to handle that. Now, at the end of this lecture, you will be able to explain the issues of limiting factors. Why are they limiting factors? Why are they limiting your attainment of your objective. You're also going to identify limiting factors. So it means that if there are certain things that are tending to limit your attainment of your production plan, you are going to identify the limiting factor. Then you're going to also carry out what we call limiting factor analysis to formulate an optimal production plan. That is a plan that maximizes two things. First, it maximizes your contribution and it increases your profits. One of the functions of management is to make decisions on how to run a business. Now, these decisions will involve making choice of what should be done, as what functions should be done, what products should be produced, and they have different choices to make as to which should not, what should be combined, and all that. To help managers make good quality decisions, they need reliable and relevant information. So the information that management needs are to be relevant and should be reliable. It is often assumed that in budgeting, a company can produce as many units of its products or services as is necessary to meet the available sales demand. So sales demand is therefore the factor that sets a limit on the volume of production and sales in each period. Hence, there could be a shortage of key production resources, such as an item of direct materials, or skilled labor, or machine capacity. In these circumstances, the factor setting a limit to the volume of sales and profit in a particular period is the availability of the scarce resource, because the sales is now being restricted by that amount the company can produce. And so it means that in your budget, the first thing to do is to set your sales target. So how much you want to sell, and how do you get the volume you want to sell? You check your demand. Your customers' demand will be a key factor in making you set your sales targets. Then, what could help you? What could make you reach that target? It's other things that contribute to production. What could hinder you from reaching that target is the same factors. You know, factors of production. We know there are materials, labor, machine, some people say land. Okay, so these are factors of production. So, but most times land is not scarce, but machine, hours, labor, materials, and other factors would be scarce. Now, these scarce resources is our area of focus. Now, in this topic, we are going to be dealing with just one of these resources being scarce at a time. So we'll not be dealing with material being scarce and labor being scarce at the same time. No, we'll be dealing with just one of them. Okay, if a company makes just one product and in a production run, there is only one scarce resource, and there's only one product, the production manager knows what to do. He will simply say, please produce as many products as that scarce resource can go. Let's say you are supposed to make cake, 5,000 pieces of cake, and you have scarce resource, material. The material can make only 2,000. So you simply say, make the 2,000. But when you are making more than one type of product, let's say you are making cake and bread, both of them requires flour. And now you need, you have about flour that can go, let's say about 10 bags of flour. So all you need now, maybe you needed 12 bags to meet the demand of cake and the demand of bread, but you have 10 available. So what you simply do is make as much of cake or bread or a combination of both that could maximize my profit. That is what a smart production manager will do. And that is what we are doing here. All right. So how do we start doing this? You have to identify the limiting factors. A question might tell you that there is a restricted supply of a particular resource without telling you which of these resources is the limiting supply, is the limiting factor. Let's say, for example, the question could tell you that material available is, let's say, 70,000 kg. They can also say labor available is 25 hours or 25,000 hours in a month. So you see, these are restricted resources. But now, the question did not tell you which one of them is the scarce resource. So how do you set about identifying which one of them is the scarce resource? All right, let's look at example LF1, identifying a limiting factor. The first question, a company manufactures and sells two products, product X and product Y, which are both manufactured using two different machines. The time taken to make each product together with the maximum time available and contribution per unit and demand are as follows. Now look at the products X and Y, the hours available for machine type 1. See here, they said 10 minutes per unit. So what does 10 minutes per unit translate in an hour? So 1 unit is being made for 10 minutes. If there are 60 minutes making up an hour, and you keep making 1 in 10 minutes, 1 in 10 minutes, by the time you get to 60 minutes, you would have made 6 units per hour. That is what it's meant by that 6 per hour. Then Y, you make 1 unit of Y in 6 minutes. So in 60 minutes, which is 1 hour, you would have made 10 units, which is 10 units in 1 hour. How many hours available for machine type 1? You have a total of 3,000 hours available. Now let's look at machine type 2. 5 minutes is being spent on machine type 2 making 1 unit of X. So if you keep making 1 unit of X every 5 minutes, by the time you get to 60 minutes, you would have made 12 units of X in just 1 hour. Now, going to Y, you make 1 unit of Y in 12 minutes. You keep making one each time you make Y, spend 12 minutes. When you get to 60 minutes, you would have done 5 units of Y. And you look at it here that 4,200 hours is the available hours for machine type 2. Now your sales demand, which is the king. Your customers demand 12,000 units of X and they demanded 15,000 units of Y. Now, you know that these hours available cannot meet this demand. So which of the machine is the limiting factor? Which is the limiting factor? So let's identify this limiting factor. What is a technique when you are given more than one factors and you don't know which one of them is the limiting factor? All right, look at the solution here. You take the machines one after the other. Machine type 1, these are the products X and Y. We see that their sales demand for unit X, for product X is 12,000 units, for Y is 15,000 units, right? Now that's this. And it takes you 6 units to be produced in 1 hour. So what it means is that in 1 hour, you produce 6 units. How many hours will it take you to make 12,000 units? So you simply say 12,000 units is what you are aiming at, divided by 6 units in 1 hour. That will give you 2 hours, making the whole 12,000 units. The same thing here, if you are asked to make 15,000 units of Y, and each time you spend 1 hour, you would have made 10 units. How many hours will it take you to do 15,000 units? Simply put, 15,000 divided by 10 gives you 1,500 hours. So when you add the 2,000 hours for X and the 1,500 hours for Y, you have requirements. Our requirement, 3,500 is required for you to meet your customer's demand. But what does machine type 1 have available hours? Only 3,000. It means that, oh, you need 3,500 hours. I can only give you 3,000 hours and nothing more. That means it is shorting, or there's a shortage of 500 hours if you are to use machine type 1. What does that mean? We'll get to find out. In machine type 2, the sales demand is still required, yes, 15,000 and 12,000, Y and X. Now the hourly requirement for X, 12 units in 1 hour. So if you want to make 12,000 units, simply say 12,000 units divided by 12 units per hour gives you 1,000 hours required to make your customer's demand for X, machine type 2. 15,000 units of Y, each hour you make 5 units. How many hours do you require? 15,000 units divided by 5 units per hour gives you 3,000 hours to meet up your customer's demand for unit Y. So when you add 1,000 hours for product X and 3,000 hours for product Y, you have a total hour requirement for product for machine type 2 to be 4,000 hours. And how many hours is available? We have 4,200 hours to play with. And here the machine is, the demand is saying, oh, you have 4,200. Just give me 4,000 out of it. That means you have a surplus of 200 hours. So it means that we have no problem with machine type 2. With machine type 2, we can do all our customers' demand. But machine type 1, we are short of 500. It means the scarce resource, the limiting factor is machine type 1. So whenever there is a shortage or a scarcity of resources, that is the limiting factor. Okay, so we've identified the limiting factor. So what are the steps in profit maximization when there is a single limiting factor? Now, how can we take advantage of the short-term decision-making when we identify limiting factor to maximize our profits? When there is just one limiting factor other than sales demand, the total profit will be maximized in a period by maximizing the total contribution earned with the available scarce resources. The approach here is to select products for manufacture and sale according to the contribution per unit of the scarce resource in that product. What does it mean? Contribution per unit per scarce resource. For you to understand, let's take the steps one after the other. There are about 6 steps for us to maximize our profits when there is a single scarce resource, which we call a single limiting factor. First of all, we need to calculate the contribution per unit of each of the type of goods produced. Okay, so what is contribution per unit? In our marginal costing class, we learned that contribution is important, and contribution is simply your sales minus your variable costs. That gives you contribution. So contribution per unit is your selling price minus your variable cost per unit. That gives you contribution per unit. So the first thing to do is to identify or calculate your contribution per unit for each of the products. Notice here that it's not a single product, even though we have a single limiting factor. It is multi-product, single limiting factor. So identify each of these products, their contribution per unit. Then go to step 2, identify the scarce resource. Now, did you see what we did in example 1, how we identify the scarce resource? Whenever the question did not tell you which resource is scarce, you have to look for it. When there is a shortage, it means that is scarce. All right. Then, most times the question will give you the scarce resource. And when it does, then there is no need to carry out the operation in example 1. Just identify that that is the scarce resource. All right, so that's identifying the scarce resource in step 2. Then step 3, you will need to calculate the amount of scarce resource per unit used by each of these types of goods produced. Most times, if you are given the scarce resource, you may be given the scarce resource per unit. If you are not given, then you must look for a way to get this scarce resource per unit. Now, after doing that, you go to step 4. You divide the contribution per unit of each of the products by the scarce resource per unit to get what is called contribution per unit of scarce resource. So what it means here is the contribution per unit you got in step 1, that will be the numerator. The amount per unit of scarce resource gotten in step 3 will be your denominator. So you are simply saying step 1 divided by step 3, that will be your result in step 4. All right, so let's go to step 5. Step 5 is to rank the product in order of contribution per unit of scarce resource. Means that if you have 4 products and you've done step 1 divided by step 3 to get step 4, you will now look at them to rank. The one that gives the highest result is ranked first. The one that gives the next highest result is ranked second. The one that gives the lowest result is ranked last. What is the essence of the ranking? The essence of the ranking is achieved in step 6. Construct a production plan based on the ranking. So what it means here is your production plan will be like this. You will satisfy the product ranked first until it is fully exhausted before you move to the product ranked second, and you satisfy it to its fill before it goes to the product rank 3. Perhaps when you are in product rank 3, you may not be able to satisfy everything in 3. You will satisfy as much as the remaining resource can carry, and you stop so far. So it means that maybe the product rank 3, your customer may be demanding 5,000 units, but the remaining resource after the one ranked first and second have been fully satisfied, maybe you now have something left over that can take just 2,000 instead of the 5,000 for the product rank 3. You simply do the 2,000. So it means here you have severely limited what could be produced in the product rank 3. So you see where the name comes up. Limiting factor has not limited what should be produced. Then if you have a 4th product, the 3rd one has been severely limited, the 4th one will not be produced. So that's your production plan. And when you carry out this plan, you will ensure that what contribution you make from this plan is the maximum contribution possible. Now, I want you to note something here. This amount of scarce resource, when we divide it from the step 1, that gives you your step 4. This step 4 result, which is contribution per unit of scarce resource, the usefulness ends when we have done the ranking in step 5. The usefulness of contribution per unit of scarce resource ends when we have done the ranking. When we are doing our production plan and we are asked to calculate the contribution, we do not use the contribution per unit of scarce resource as our contribution in the production plan. We use the contribution per unit in step 1. So I'll repeat that. The contribution per unit of scarce resource we obtain in step 4, that is the only place we will use it. It is only useful to help us achieve ranking. That's all. When ranking is done, we say thank you to contribution per unit per scarce resource. You've done a wonderful job. Your production plan, contribution per unit is what is needed to get the maximum contribution. I believe that point is taken. Okay, so let's look at example LF02 limiting factor analysis and see how we can solve a question. All right, so a company manufactures and sells 2 products, product X and Y, which are both manufactured using 2 different machines. Now, can you notice something here? This is the same question we solved in LF0.01, but there is only one difference between this question number 2 and question number 1. Everything is the same except the last line before the required. Now, did you notice here that there is contribution per unit here of 7 naira in product X and 5 naira in product Y? This was missing in the first question because it was not needed for us to identify the scarce resource. Did I say there is only one difference? No, there are more than one difference. Look at the requirement. Given that machine 1 is the limiting factor, okay, in question 1, we didn't know the limiting factor. We found it ourselves. That was one way the examiner could set the question for you to find the limiting factor. That will be the first part, and then solve the second part. But here in this second question, the limiting factor has been told us. Machine 1 is the limiting factor. What is the optimal production plan? Now, did you notice here that optimal production plan is our step 6? So it means that when you want to climb a step, you can't jump to step number 6 without following step 1 to 5. So if you are asked to do step number 6, know that you do the whole works, the whole step. Now, we are asked to look for the production plan that maximizes annual contribution and hence profit, which the company should adopt. So how do we do this question? All right, so let's look at the solution right now and let's see how we can solve that. Solution staring us in the face. All right, let's look at the technique here. Limiting factor analysis. Let's follow the steps one after the other. Step number 1. Okay, it pays for me to go through, open the steps so that we'll look at it again. Calculate the contribution per unit. In this case, we don't need to calculate it. We were given as a bonus 7 naira and 5 naira for X and Y respectively. And that's it. Second one, identify the scarce resource. It was identified for us, machine type 1. So step 1 and step 2 are bonuses. Step 3, calculate the amount of scarce resource used by each type of goods produced. We don't need to even calculate it. We were told. Step 3 was a bonus. Machine type 1, 10 minutes per unit, or 10 minutes per unit rather, or 6 units per hour. Which do we take? Any of them. 10 minutes for 1 unit. Okay. Now, since it's the step says per unit, the scarce resource per unit, not per hour, we're going to take 10 minutes per unit. So machine type 1 is 10 minutes per unit. Machine type 1 for Y is 6 minutes per unit. So that's what we are taking here, 10 minutes per unit. And what are we going to do next? We are going to do step number 4. Divide the contribution end, which is step 1, by the amount of scarce resource per unit. So step 1 divided by step 3. So step 1, we have 7 naira divided by 10 minutes. What will that give you? It will give you 0.7 naira per minute. So it's not every time you'll be thinking in terms of per hour. This is in per minute. You can always convert it to per hour if the occasion requires by dividing by 60. That will give you per hour. So here, it means that the contribution each minute that X is making is 0.7. Whereas Y in every minute is making 0.83 naira. So which of them is making a higher contribution per minute? Is Y. And so we have ranked them. Y will be satisfied first. So it means that we will satisfy Y as much as possible. Then we'll now go to X. What does that mean? And that's the production plan. Now look at how the production plan is drawn up. The rank is here, showing that the first, second, perhaps third, fourth, fifth, like that. We have only 2 products, so we have first and second. What are the products? The first was Y, and the second was X. The next thing to do is, how many sales units can we satisfy of this product, X and Y? Okay, so let's start by trying to find out what is the sales unit for for Y, because Y is what will be satisfied first. The sales demand is 15,000. So you ask yourself, can you satisfy the whole 15,000 given the available resource of 3,000 hours? All right, so let's do it. If we are to use 15,000 units, and remember, if you are to take 15,000 units, how many hours will it use? How many machine hours? Remember what we did here. Remember we said 6 minutes in 1 unit. If you want to make it per hour, you can simply say 6 divided by 60. It means 0.1 hour per unit. And that's it, 0.1 hour per unit. If you multiply 0.1 by 15,000 units, what would that give me? 1,500. So it means that 1,500 hours is what is required to satisfy all of units of product X, of product Y. Now, what is the contribution? I said the contribution by limiting factor is no more useful after we have done ranking. What is useful now is the actual contribution. And so Y contributes 5 naira. So when we say 5 naira multiplied by 15,000 units, we are going to be getting 75,000 as our total contribution. And that's fine. So you see here, 1,500 hours has been used up, and we have a total of 3,000 hours. So without being told, since we have 2 products, it means that the second one will automatically take in 1,005 and nothing more. Normally, X should take more than 1,500. Let's see. X, we needed 12,000 units. So let's see, 12,000 units required for X. And we have 10 minutes per hour, 10 minutes per unit. So if we have 10 minutes in 1 unit, convert it to an hour. 10 divided by 60 will give you 0.1667. Multiply that by 12,000. It means here that you need 2,000 hours to make up product X. But we have 1,005 available. It means that you can never do your 12,000 units using the 1,005 available. So you have to cut it down. So can you see the arrow here? In Y, the arrow was moving from left to right. But when we get to the last one, when we have a balancing figure here of 1,500, we no longer move from left to right. We move from that balancing figure, start moving leftward. We ask ourselves, how many sales units can we do in 1,500 hours? So what we'll do now is, we will say 1,500 hours is what is required, and you have 10 per unit. 10 per unit, meaning that 6 in 1 hour. 6 units in 1 hour. So what you simply do is 1,500. Okay, another way of doing this is this. Let me make it easier. 1,500 hours is what is available. You can convert it to minutes. You can convert it to minutes. How do you convert it to minutes? By multiplying by 60. So 1,500 hours is as equivalent as 90,000 minutes. If you have available 90,000 minutes, and each product of X requires 10 minutes, so you simply divide it by 10, you have your 9,000. So 9,000 units is what is required of you for product X. And what will be the total contribution? 9,000 multiplied by 7 naira. So that will give you 63,000 naira. So you can see how we got our total contribution. And when we add the 2 of them, it gives you 138,000 naira as a total contribution. So it means now your production plan is as follows. Since Y is ranked first, the company will make as many of Y as possible. The most that can be sold of Y is 15,000 units, which would take 1,500 hours. You have to do 10 units per hour. And the company has 3,000 hours available. And so all these can be produced. Now the company will be left with 1,005 after Y has been produced. X is ranked second, and the most X can produce and sold is 12,000 units. But the 12,000 units will use only 2,000 hours, which is more than what is available. That means that we must cut it down to 9,000 units, which is found by 1,500 at 6 units per hour, which gives us the remaining 1,005. So it means here that we have scaled down our production of X from 12,000 to 9,000. So can you now see the technique? That 6 steps should never be forgotten. That is the key. That is the secret of handling limiting factor production. These 6 steps I just gave you. Okay, for the sake of emphasis, I will reiterate the 6 steps again. Always look for the contribution per unit of each of the goods or types of products. Secondly, identify the scarce resource in the question. Thirdly, look for the amount of the scarce resource per unit. It may be given to you, it may not. You need to find it. Then fourth step, divide the contribution per unit, step 1, by the amount of scarce resource per unit, step 3, to get contribution per unit per scarce resource. Then step 5, you need to rank the product in the order of the contribution per unit of the scarce resource. Step 6, you create a production plan based on your ranking. All right, so we've done that steps in question 2. Let's look at question number 3, and let's see how we can also apply these steps. All right, a company makes 4 products, A, B, C, and D, using the same direct labor workforce on all the products. The company has no inventory of finished goods. Direct labor is paid 12 naira per hour. Now notice this figure, we're going to use it, and I'll show you where you will use it. Okay, direct labor is paid 12 naira per hour. Now, the way my mind is working, I'm thinking direct labor hours is likely going to be the scarce resource. But let's find out. To meet the sales demand in full will require 12,000 hours of direct labor time. So you see what is required here is 12,000. How do we know? We're going to test it. Only 6,000 direct labor hours are available. So you see there's a shortage of how many hours? 6,000 hours. Now, budgeted data for the company is as follows. Now look at the budgeted data. The annual sales demand for all the products A to D, we have 4,000. 5,000, 8,000, 4,000, respectively. Then look at the details of cost. Now, these are per unit costs: direct cost, direct material cost, direct labor cost, variable overhead cost, fixed overhead cost. Now, if you noticed here, under you see full cost. Now that will make you remember your marginal, your absorption costing. Absorption cost is a full cost method where you have all your variable costs and your fixed cost added together to give you your full cost. And we told you one of those things is we use it to know our selling price. And now this is how our selling price has been determined, and our profit per unit is given to us here. Okay. Did you notice something here? Profit per unit is given to us. Contribution per unit is not given to us. Calculate the optimal production plan. Once again, let's activate those 6 steps. Let me go to the solution. Then let's remind ourselves the 6 steps. The 6 steps says compute the contribution per unit. It was not given to us. So how do we get it? We need to extract all the variable costs. We have direct material costs, direct labor costs, variable overhead costs. These were given the questions. So you pick them as it is. Don't pick the fixed production costs. So when you add them together, like for product A, you have total variable cost of 11 naira. For product B, you have 22 naira. For C, you have 9. For D, you have 18. Now, bring the sales price, which was given to us here. You can put them as denominator, and you know what to do to get your contribution per unit. Simply say sales price minus your variable costs. So your 15.5 in A minus your 11 will give you your 4.5. So don't be surprised that because I didn't put bracket in anyone, so you think everything is addition. No. Sometimes even when you don't put brackets, you can still do your subtraction and you still score your full mark. Another student could decide to put sales price up first and underline it. And we now say less variable costs. And we start listing the variable costs and get a total variable cost under like this and also underline it. Then underneath you have contribution per unit. We'll say sales minus variable cost. Now we have our step 1, contribution per unit has now been calculated. 4.5, 7, 2.5, and 9. What is step 2? Step 2 is identify the scarce resource. It was given to us. The scarce resource is labor hours. Labor hours. Okay, so we have that. Now, the third thing is find the amount of scarce resource per unit. So now we have labor hours. We now need to know labor hours per unit for each of the products. Were we given? Surprisingly, we were not. What we have here, direct labor, is costs. Direct labor costs. What we need is direct labor hours. So how do we now get the direct labor hours? That is where this 12 naira comes to help us. Now it means this, how do we use it? Now, every hour of direct labor, you pay 12 naira. For every hour, you pay 12 naira. So it means that if you had paid 6 naira for 1 unit of A, how many hours did you spend for you to have been paid 6 naira? You simply say 6 divided by 12 naira, meaning you spent 0.5 hours. You spent 30 minutes. And so that's what we did here. 6 divided by 12 and gives you 0.5. So you see this 6, 12, 3, and 9, these are the labor costs for each of the products. Now this labor rate of 12 naira is constant in all of them. So you simply divide the up one here, the 6, divide by 12. So here 12 divided by 12, it means you spent 1 hour per unit. Okay, so now we have our amount per scarce resource. I want us to do something. Let's see. How can we do this? Okay, let's do it together. Product A, you require 30 minutes, which is 0.5, to make 1 unit. When you multiply 0.5 times 4,000, total hours is 2,000 hours that will be used up. 2,000 hours. Go to product B, 1 hour per minute and 1 hour per unit. 1 hour multiplied by 5,000 units will give me 5,000 hours. Add it to the 2,000, you have 7,000 running total. 7,000. Product C, 0.25. So 0.25 multiplied by 8,000 units gives me 2,000. Add it to the 7,000 running total, you have 9,000. The new running total is 9,000. Then you have 0.75 multiplied by 4,000. That's 3,000. So add it to the 9,000 running total, you have 12,000 hours. So did you see here that the question says to meet the sales demand in full will require 12,000 hours of direct labor time? We just confirmed that. This is not needed in the question, but for the sake of tutorial, we just have to confirm that. Never do this in the question to confirm if that is true. You don't have the time. Just believe the examiner that he has done that for you. Okay, so it means that we need 12,000 hours to finish the whole work in full. But what is available to us is 6,000 hours. That's why we're not doing this scarce resource computation. Now that we have our limiting factor per unit, we'll go to step 4. Our step 4 is the contribution per unit per limiting factor. So we simply say step 1, 4.5, divided by step 3, 0.5. So 4.5 divided by 0.5 will give you 9. And so that's how we got this 9. The same thing here, 7.0 divided by 1 will give you 7.0. And 2.5 divided by 0.25 will give you 10. And 9 divided by 0.75 will give you 12. Now, step 5, ranking. Ranking. How do we rank them? Which one of them is the highest? Product D with first. Product C with second with 10 naira per limiting factor. Product A is a third, and product B is the last, the fourth. Step 6, go and prepare your production schedule. Prepare your production schedule. Now, rank 1, 2, 3, 4. In the order which product is the first is D, followed by C, then A, and here. We need 6,000 hours to be satisfied. How do we satisfy them? First of all, satisfy product D. Let it be fully satisfied. So what do? Product D required 4,000 hours. Okay, so 4,000 hours and 4,000 units, I beg your pardon, 4,000 units. Now, look at the scarce resource here for D. If it has 0.75 hours, 0.75 hours per unit, multiplied by 4,000, it gives you 3,000. It means 3,000 of your scarce resource will be used here when we make the whole of 4,000 units. And you see that 3,000 is a far cry from 6,000. That means we can fully satisfy D. And what is the contribution for D? D earns 9 naira per unit. So multiply this 9 by 4,000. You have your 36,000 as contribution. Enough for D. We go to the second one, which is C. Can we fully satisfy C? How many does C need? C needs 8,000 units. Can we satisfy it with the remaining 3,000 hours available? Let's find out. Now, 8,000 is what we have to satisfy. And look at C. C scarce resource is 0.25. So we simply say 8,000 divided by 0.25. It means, multiply 8,000 multiplied by 0.25 gives us 2,000. 2,000 out of the 3,000 labor hours will be used to satisfy all of C. By all means, do all of C. Now, can you see the arrows going from left to right, meaning we move that direction? Now, the contribution per unit of C is 2.5. So please don't confuse 2.5 here with 0.25. This 2.5 is contribution per unit. This 0.25 is limiting factor per unit. Okay, so when we contribute, I multiply the contribution by sales unit, we have 20,000 naira. Now let's go to A and ask ourselves, can we fully satisfy A? Let's see. A needs 4,000 units. Okay, so let's do it. 4,000 units. And what is the what is the limiting factor per unit is 0.5. So 4,000 multiplied by 0.5 will give you 2,000. But alas, we've used 3,000 for D, 2,000 for C. What is left is 1,000. So we cannot satisfy all of A, which require 2,000. So we'll make do with the remaining 1,000 to make A. So now you see the arrow pointing backward. How many units can 1,000 hours go? So what we do here is we look at A, 0.5. And so when the arrow was moving from left to right, we usually multiply the sales figure by the direct labor hours per unit. But now when moving from right to left, we do the inverse. Instead of multiplying, we divide. So 1,000 will be divided by 0.5. It means you can only do 2,000 units. Come to think of it, 2,000 now multiplied by 0.5 will give us 1,000. So that way, move the normal direction, we still get the same thing. So 2,000 units multiplied by the 4.5 contribution gives you 9,000. Now, all the resource, the scarce resource, has been used up in D, C, and A. For B, no labor hour is required. That means we cannot do B. So we'll say 5,000 will satisfy you. We can't do B. We can only do the other ones that will give us a maximum satisfaction, the maximum contribution also. So it means that if you do it in this production plan, it's called optimal production plan. Your contribution will be 65,000. That is the highest contribution you can make. Any other way to achieve this labor hours of 6,000 without following this plan, your contribution will be less than 65,000. And that your profit will be not optimal. So once again, the 6 steps have been brought to play and we have applied them perfectly. Now let's take our last question and let's see how the 6 steps once again be brought to play. The company makes 4 products, W, X, Y, and Z, using the same single items of direct material. Now, you see the focus is now direct material. The last example, it was labor. So you see here your limiting factor could be machine, which we learned in example 2. Machine hours could be direct labor hours, which is what we did here, could be materials. But take a look at this one. A company makes 4 products, W, X, Y, and Z, using the same single item of direct material in the manufacture of all the products. Budgeted data for the company is as follows. We have the products all spread out for us. Annual sales demand as usual, 4,000, 4,000, 6,000, 3,000. That's fine. Now look at the costs. And remember, we are using absorption costing. We have a full cost, we have our selling price, and we have our profit here. That's fine. Now, take note of this next statement. Due to restricted supply, only 78,000 naira of direct materials will be supplied during the year. Now, can you tell me the limiting factor here? Okay, let me reserve it for step 2 when we are taking it. Required, identify the quantities of production and sales for each product that would maximize annual profits. Now I added a note here. This question does not tell you the amount of material, but it does give you its value. The analysis can proceed in the usual way using contribution per value of material rather than contribution per amount of material. I'm going to explain that to you in the solution. Okay, so solution now, solution time. Take note of how this question is being solved. Step number 1, look for your contribution per unit. So you see the first time I put selling price down, and I get a contribution. But now look at how I did this. Sales price up here, then you start bringing your elements of variable costs. Direct material, direct labor, variable overhead, you put them in bracket, and your contribution per unit has been gotten. I believe you're happy with this type of method. Fine, you can adopt this. Then, what is your scarce resource? Now, your scarce resource is not materials. It's your material costs. Your scarce resource is your material cost. Yes, you know it's all connected to material. It's your material costs and not direct material. So it means that this thing is not giving us in kilogram or in units. That's why I said it's not direct material usage or so. It's given to us in naira value. So it is material costs that is your limiting factor. So step 3 is to look for the direct material cost per unit. Now, it was given to us, surprisingly, direct material cost per unit. Remember when we did labor, we said it was not labor cost, but labor hours. And labor hours was not given. We calculated it. If we were to do direct materials as our limiting factor, we would have been told how much per unit or per kg each material will cost, and would have followed the same way to get material usage. What they told us is direct material costs. That is our limiting factor. So you see from the notes, from even the question, you can see what the limiting factor could be. So it was given to us, and let's apply it. We have our step 3. Easy for us, easy peasy. Then we go and do our ranking. Okay, contribution per limiting factor, step 4. So step 4 will be step 1 divided by step 3. So 40 divided by 20 divided by 4 will give you 5. 48 divided by 8 will give you 6. And 42 divided by 6 will give you 7. Step 5, ranking. So 8 is ranked first, 7 is ranked second, 6 is ranked third, and 5 is ranked fourth. Step 6, production schedule. Your ranking. Okay, your ranking 1 to 4, the products in order of ranking, all lined up. Then you don't put anything in the sales unit. Go to direct material cost, which is your limiting factor, and put the total you want to achieve under here, 78,000. How do we achieve that? Okay, I did a series of workings here underneath. So let's follow this working. So let's go down here and look at the workings. Now look at the workings now. For the ranking number 1, which is W, we have 4,000 units to be achieved, right? And if the direct material cost is 5 naira, when you multiply 4 times 5, gives you 20,000 naira. That's how we got our 20,000 naira. Then product Z is the next. Product Z, we need 3,000 of product Z. Sorry, we need 3,000 of product Z. And when you multiply it by the cost of 6 naira, that gives you 18,000. That's it here. So 18,000. Then we go to Y. How many of Y do we need? Y, we need 6,000. Oh, wait a minute. 6,000. When you multiply 6,000 by 8, 6 times 8 will give you 48,000. But hold on, 20 plus 18 will give you 38. We need 78 here. So the difference will be 40. And so Y has already told us we need 48. So but 40 is available. And so we'll resort to using 40. 40 divided by 8 will give us 5,000. Or simply put, 5,000 times 8 will give you 40. When that is done, X is 0. Now look at the contribution. How did we get the total contribution? We go back and say W multiplied by 40 naira. X was 0 multiplied by 20. Y was 5,000 multiplied by 48. And Z was 3,000 multiplied by 42. We have all of that and we replicated them here. Our total contribution is 526,000 naira. So you see, we have come to the end of the topic. At the end of this topic, we were able to explain the issues of limiting factor. Okay, now we explained that limiting factors are those things that affect our production in such a way that we could not achieve what we set out to aim, what we aim to achieve. It means that our aim is to satisfy our customers' demand, the annual sales demand. But there are certain factors that are hindering us from achieving that. We have to identify the factors. We carried out a test to see which of these available factors is the scarce resource. And how do we do it? We checked out what is required of that scarce resource to fully produce our annual demand. That is on the one hand. Then we check how many of these scarce resources in total is available. Now, when the requirement exceeds what is available, it means there is a scarcity. That is the limiting factor. Then we also carried out a limiting factor analysis to formulate a production plan, which gave rise to the 6 steps that we are playing with this topic. For the sake of review, I will mention the 6 steps again. Step 1, calculate your contribution per unit. So you could calculate or you could just extract it. Secondly, or that's step 2, identify your scarce resource. It will be given to you in the question, or you could go and get it yourself by test. Step 3, calculate the amount of scarce resource per unit. Be given to you. It could also be you need to do is to get your contribution per limiting factor. Step Step 5 is to do your ranking. Your ranking is based on step 4. Rank accordingly in descending order. So the one that is the highest result is ranked first. The one that is the lowest result is ranked last. Step 6, make your production plan according to your ranking. So you saw the tables that we use there, and when you are checking your contribution, please use the actual contribution per unit and not the contribution per limiting factor. If you remember these 6 steps so clearly, then you are good to go in this topic. Thank you so much for enjoying today's topic. In our next class, we are going to be extensively taking this limiting factor to the next level by teaching you the linear programming. So come prepared when we'll be having a swell time talking about that topic. So thank you once again. Happy to see you, even if some of you are not showing your videos. Okay, maybe it's time for you to show your videos, and we'll say our goodbyes and we'll go. Okay, for the next 30 seconds, we are going to be in class. So from me to you, thank you for coming to class. I appreciate your listening to me, and take care of yourself. Thank you. Bye.